Morning. My name is Scott Gustafson, and I make apps. But I also make hardware. And that's what we're going to talk a little bit about this morning. This is an example of Bluetooth hardware. It's a very small little package. The only reason it's so big is because there's a big battery on the back. And all this is doing right now is telling me it's about 23 degrees in here, about 73 degrees Fahrenheit. It's very easy to make this little kind of stuff. And we have several presenters who are going to come up here and tell you all about how you can use either TI's chips that are actually inside this little TI part, Blue Giga's chip, which is actually driving this little guy, and how to do things like maybe your app needs to monitor heart rate. So your customer has a Polar heart rate monitor or a Wahoo, and you want to know, are they active? Or you have a little Fitbit on your belt, and you want to know how many steps are they taking. Maybe you want to make a little reminder app that says, hey, it's time to take a break. You can monitor their heart rate, you can monitor their movement. Maybe you just pop up an alarm. These are all things you can do with a little hardware and a little iOS. So there's a GitHub address up here. That's where these presentations are all at that you're going to see today, along with some sample code. Please go copy it if you want. And if you want to contact me later, that's my email address. This session we're going to do a little different. We're going to go through about 4 presentations. And then immediately following this, we have a lab right behind this wall in this little room over here. All of the presenters are going to be over there with hardware to play show and tell and answer any questions. So if you want to come see any hardware and actually try out something or ask some questions about maybe your application and how you can use some hardware, come talk to us. With that, I want to introduce our next presenter, which is Bob Crescent, going to give you a little introduction on Bluetooth.
Good morning. So my name is Bob Crescent. I'm excited to talk with you this morning about Bluetooth Low Energy. In fall of 2011, Apple introduced the iPhone 4S. And with the introduction of the iPhone 4S, Apple brought Bluetooth Low Energy technology to the mobile platform. And since then, every major release of Apple hardware that is either desktop or is mobile in the iOS realm all has included Bluetooth Low Energy technology and capability. So what we're really excited to bring to you this morning are some hopefully novel ideas on how you can use Bluetooth Low Energy in your applications as iOS app developers. So let's start with some basic definitions. What is Bluetooth Low Energy? Well, basically, it's an extension of a technology that you've used for years. So Bluetooth Low Energy is another wireless radio standard technology, but it brings a few new things to the table. Primarily, it brings low power, low range, low latency, and low bandwidth applications. And so when you look at that, the first thing that comes to mind is sensor technology, like Scott mentioned. And so Bluetooth Low Energy's claim to fame is the ability to very easily make a connection with a sensor, communicate that data to it, and then tear down that connection again. So it's great for primarily sensor-type applications. So the other thing that makes kind of exciting about Bluetooth Low Energy is how the embedded systems market space has really changed in a short amount of time. If you look at sensor technology in the last 10 years, everything has been vectoring in a really exciting direction. If you take something simple like a humble accelerometer, and if you look at the cost of that piece of hardware, and if you look at the capabilities of that hardware, its sample rate, its resolution, what it's able to do, all those things have improved for the better in the last 10 years, to the point where these sensor technologies, combined with Bluetooth Low Energy, allows you to do wireless communication using something really simple, like a coin cell battery. And that technology can last for over a year or maybe 2 years or more, depending on how long and how much you communicate with a mobile device. So not only has the sensor technology gotten better, and not only has battery technology gotten better, but now we all have mobile computers in our pocket with things like Core Bluetooth, the framework that Apple has given us to communicate with Bluetooth Low Energy technology. So as a hardware developer and as an iOS developer, I kind of feel like a kid in a candy shop. I've waited for this moment for 15 plus years as an engineer. It's such an exciting time to be innovating in this space. So how have hardware developers responded to this candy shop? What have they done as a result? Well, since 2011, we see tons of devices now flooding the market space. If you went to the Consumer Electronics Show just a few weeks ago, there are whole sections, whole halls now that are filled with Bluetooth Low Energy technology. And so we see lots of different applications, whether it's a heart rate monitor like you see there in the upper left-hand corner, or a bicycle computer like a cycle speed and cadence sensor, or whether it's Nike's new FootPod that goes inside their shoes and measures things like pace, or maybe the new Fitbit. The One currently has Bluetooth Low Energy technology in it, and the thing lasts forever. I mean, it's got a good 3-5 day type lasting time in it. Or whether it's something like this key fob that's in the upper right-hand corner, so when your kids walk away from you, or you lose your keys, or you can't find your wallet, you can just tap a button on your iPhone and then go ahead and find that device. We see tons of great hardware examples now flooding the marketplace. And the beauty of Bluetooth Low Energy is that you as iOS app developers, we can take advantage of this. And so hopefully this session is going to flesh out some of those ideas and how you can do that. Now these are great devices, but many of us in the room have another device in your pocket right now that can communicate with Bluetooth Low Energy. And that's your iPhone 4S or greater. Now with iOS 6, not only can you design Bluetooth Low Energy applications that talk to these sensors, but now you can use Bluetooth Low Energy to talk to other iOS devices. We think there's a dramatic number of applications that you could do with this. I didn't put it on here, but you could put your OS X Mac desktop device on here as well. So if you're interested in iOS to iOS communication, I have a GitHub link at the end of this presentation. You can go check it out. It's a great example of how to get two iOS devices talking to one another. So Bluetooth Low Energy, tons of great applications, tons of great ways that you as developers can take advantage of it. So you might be wondering, well, Bluetooth, what's the difference between Bluetooth and Bluetooth Low Energy? And which one should I use for my application? Well, here on the screen I have two very similar devices. As a matter of fact, both of them are activity trackers. Both of them tell you amount of calories burned or number of steps taken. They both essentially do the exact same thing. Nike's device on the left, the Nike Fuel, is classic Bluetooth powered. The device on the right by Fitbit is Bluetooth Low Energy powered. So they're both in the same market spaces, but they decided to use different radio technology. Well, why would they do that? It's important to take a look at some of the claims to fame of both classic Bluetooth as well as Bluetooth Low Energy. Lots of people think, well, Bluetooth Low Energy, is that going to replace classic Bluetooth? You know, it's not. If you look at this chart, you actually see very different reasons why you would choose classic Bluetooth for an application as opposed to Bluetooth Low Energy. Now, at the onset, we described Bluetooth Low Energy as a low power, low latency, low bandwidth, low range type of device. And so these numbers on the chart quantify that for you. So when you look at this, the latency is probably 20 to 40x lower, which is pretty astounding. Power is about 10 to 15x depending on what you're doing. Range is about half. But probably the statistic that is the deciding point for many hardware providers who are trying to pick a radio technology is that throughput. Bluetooth Low Energy has about a third of the throughput as a classic Bluetooth technology. So at 300 kilobits per second, for instance, you're not going to push audio over Bluetooth Low Energy. It just does not have the bandwidth to make that happen. The other thing that I'll point out here is a couple of great things about Bluetooth Low Energy. It may not be able to do audio, however, the profiles for Bluetooth Low Energy devices are completely open. So there's actually published standards on developer.bluetooth.org that describe exactly how hardware devices should communicate to other devices. And those profiles are open and completely established. So I was thinking about this morning. I walked from the Intercontinental. So if you haven't done that, do that. It's kind of a good walk. I'm from Colorado. We walk everywhere, I guess. And I was walking, and I have on my wrist a Kickstarter project from a company called Mio. And they have a watch called an Alpha. And the Alpha watch has two really cool pieces of technology in it. It's got a heart rate monitor in it, and it also has a Bluetooth Low Energy radio. And it's just astounding to me that I could get this in the mail. And I already had an application that I had developed that does heart rate monitoring over Bluetooth Low Energy. I literally turned on my Mio, turned on my application, and was immediately able to talk to it. I didn't participate on their hardware development team. I don't have their SDK. I don't know what schematics to use. I don't even know what radio technology is inside of it. But I don't care. As an iOS app developer, understanding core Bluetooth and Bluetooth Low Energy, I'm able to take that data and put it into my application. That, to me, is one of the most powerful and exciting things about Bluetooth Low Energy. Any app developer with experience in iOS app development can talk to any hardware that is Bluetooth 4.0 enabled, and that's the most exciting thing for me. Another thing that's really exciting, and our customers have expressed a lot of excitement about this, is that Bluetooth Low Energy does not require participation in the Made for iPod program. So MFI is required for classic Bluetooth. It's not required for Bluetooth Low Energy, which means any one of us can create whatever devices we wanted, and we just have to go through the normal Apple App Store review process. Again, that just opens the door for a flood of potentially really exciting applications. Now, another kind of gotcha that usually happens with developers that are new to Bluetooth Low Energy is the size of the number of bytes that you can transmit per packet, which is limited to 20 bytes. And usually when I say bytes, you're like, he must have meant kbytes or megabytes or gigabytes. No, it's 20 bytes. So the largest packet transmission size is 20. And this really hints at the nature of how this is a sensor type of application. 20 bytes. Great for heart rate, or the amount of light in the room, or an ultrasonic distance. But can you do file transfer with Bluetooth Low Energy? Not one bit. So hopefully this is a good comparison. If you have any further questions, I'll be in the lab after this. I'd love to help answer any specific questions that you have on comparing classic Bluetooth versus Bluetooth Low Energy. So what are the basics of connecting your mobile device to either another mobile device or to one of these accessories? Well, we need to talk briefly about how that connection process occurs. So the way this starts is you have a mobile device like an iPhone 4S or an iPhone 5, and it is a scanner. It's literally scanning for Bluetooth Low Energy devices. And you'll use a class that's part of the core Bluetooth framework, an object called CB Central Manager. And with CB Central Manager, you'll begin scanning for peripherals that contain certain services. So the iPhone is looking, and your peripheral is broadcasting. And it's broadcasting an advertisement packet. And it's saying, this is who I am, these are the services that are available, this is the type of data that you can get out of me. And if the scanner is interested, it can initiate a connection. And so all that connection logic and connection management is still done through CB Central Manager. So once a connection is established, then iOS sees that object as a peripheral, and it gets assigned the CB peripheral object. Now, both CB Central Manager and CB peripheral have delegate methods associated with them. So when new data comes in, CB peripheral and the delegate methods get that data, and you're ready to do something amazing with it. So we have CB Central Manager, great class to go check out in the core Bluetooth documentation, and CB peripheral once the object is connected. Now, before these other guys get on stage and talk more about the details, there's a couple of other terms that are really important when dealing with Bluetooth Low Energy. Even if you're doing iOS to iOS communication, it's critical to keep these three last terms in mind that I'll bring up to you. And those are called profiles, services, and characteristics. You can think of a profile as a general way or kind of a class of describing a device. So on the screen are 4 examples of heart rate monitors. They're very different. They have different form factors. They have different sample rates. They have different battery life. But all of them are of the heart rate profile. They're all heart rate objects designed to give you heart rate data. Now, each of them give you that data, but also some of them give you things like transmit power or battery that's life's remaining. And so each one of them also has a unique set of services associated with it that are available. And so this particular device has a heart rate service, a device information service, and a battery service. Bluetooth 4.0 data is structured into these characteristics and services. So this has 3 services, and your app can choose to be notified when values in those services change. And so as an example, it may be that you just want the heart rate measurement data. Well, that will be a particular characteristic of a particular service. And so in this case, there's a unique identifier given to that data, and here it's hex 2A37 for heart rate measurement. You'll get an NS data byte that represents that heart rate measurement data, and that heart rate measurement is part of that heart rate service. And so there's many other services potentially and characteristics that you can get. If your device has a battery service, it probably also has the battery level characteristic. And so you can look for notifications in hex 2A19, which is part of the battery service, 180F. You get the NS data, and now you can do something with that data. So hardware manufacturers are beginning to conform with standards that are published on developer.bluetooth.org. So if you go there, you'll see a list of open standards, and hopefully that represents devices in the future that are coming. Now, in case you don't want to build a device that conforms to this standard, you can also do 128-bit private services or private UUIDs, and now you can transfer any data that you want. So even if you don't find an accelerometer on developer.bluetooth.org, there are accelerometer technology available. So coming up here in the presentation, we're going to dive more into the details of how to communicate with sensors. And I believe we're also going to get a demonstration of TI's sensor kit. This is a really cool device. It's got multiple sensors in it. It costs $25. It's got an LE radio in it. And you as developers with no MFI access can immediately purchase this device and start talking to it. So I really appreciate your time. There's a couple ways you can get a hold of me if you have any questions. Twitter is up there. You can send me a direct email. All these slides are also on GitHub, including the iOS to iOS communication source code, so feel free to grab that. Also, if you're interested in just kind of playing around with Bluetooth Low Energy, we have a free app that's on the App Store called BTL Explorer. It's just an app that scans, can find devices, connect to it, enumerate services and characteristics. And there's a huge update coming on February 1st to BTL Explorer that allows you to write and read from any Bluetooth Low Energy device. So thanks for your time, and enjoy the rest of the session. Thanks.
Hello. Hi, my name's Sandeep Kamath. I'm an applications engineering manager with Texas Instruments. I'm usually talking to more hardware and embedded system guys, so it's a slightly different audience than I usually deal with. But I'd really like to talk a little bit more about what Bluetooth Low Energy can do for you. And it really is exciting technology that ties in hardware systems with this really big growing app development community. So this is exciting technology for us. So I think Bob kind of covered a lot of the basics here, so I'll go through this quickly. But in Bluetooth, we had the first wave, and this is typically classic Bluetooth. And classic Bluetooth, I think wireless audio was by far the main application that people were using. But it's something that's grown. There's billions of Bluetooth-enabled devices out there, and it really was just focused on replacing cables for, again, mainly for audio. I don't think it caught on too well for other applications. But now we're coming to the second wave of Bluetooth, and this is the term Bluetooth Smart Ready is being thrown around. This is the branding that the Bluetooth Special Interest Group is using. Bluetooth Smart Ready devices are devices such as the iPhone 4S, iPhone 5, new MacBooks, tablets. These are devices that are typically connected devices that are hubs, that are connected to the internet. And what's happening now is every single phone that's coming out from now on is pretty much going to be a Bluetooth Smart Ready phone, which means it supports classic Bluetooth as well as Bluetooth Low Energy. Sometimes it's called dual mode. So what's happening with the phone manufacturers is they're basically adding dual mode Bluetooth support to their systems at no additional cost to them. So this is something that's just kind of a natural evolution of Bluetooth in phones and in computers as well. But what that's doing is it's enabling these Bluetooth smart devices. So these are the peripherals, such as the Polar heart rate sensor or the Texas Instruments sensor tag. These are single-mode Bluetooth Low Energy devices that are only compatible with Bluetooth Smart Ready devices. So I can't talk to an iPhone 4 with the sensor tag, but I can talk to an iPhone 4S or an iPhone 5. And I think over time, pretty much everybody's going to have a Bluetooth Smart Ready phone. So this is a transition that's kind of happening right now, and over time is just going to be the standard. Every single phone out there, every single laptop out there will be a Bluetooth Smart Ready device. And these Bluetooth smart devices are things such as the Fitbit, the sensor tag. These are typically very low power, low throughput applications. Health and fitness is really one of the first waves of products, such as these heart rate tags, Fitbit. But there's a lot more areas which are growing here, such as automotive, consumer electronics, so these are things such as connected watches, smart home, smart energy, and even things such as industrial applications, such as industrial sensors. So this is technology that we're seeing really all over the place. Here's a few more areas such as proximity tags. This one in the upper left, the idea behind this, and there were several products similar to this that were launched in the last year, is these are little tags that run on a coin cell battery. You can stick them on anything valuable. For example, you put one on your keychain, you can put one on your dog, you can put one on your kid. And what happens is, if my phone goes out of range of the proximity tag, it'll make an alert on my phone. So it's an easy way to find things. Or another case is, I can't find my keys, I have my phone. What do? I open up an app on my phone, send a signal to the proximity tag, and that'll start beeping. Oh, there's my keys. It can work the other way around. I can't find my phone, here are my keys. I push a button on the tag, and my phone starts making an alert. So it's a very simple idea, and it ties into this low power system that we have with Bluetooth Low Energy, where we can run on a coin cell battery, and you might not even need to change that battery for a whole year. So this is something you couldn't really do with classic Bluetooth. The power was too high. So that's one of the areas we're really seeing. Medical is an area which it's a little bit slower to grow, but everything such as these glucose meters that are used by diabetics or insulin pumps, all of these companies are looking to use Bluetooth Low Energy as the standard for communicating with phones. In the past, everybody who has these glucose meters, they have to carry a whole other base unit around with them. Why do they have to do that? They have a phone. Everybody's carrying a phone around with them anyway. So it's really changing beyond just simple consumer applications. This is really technology that can change the world with medical applications like this. Then there's toys, remote controls, keyboard and mouse, lighting, home automation. Once you have control from your phone, you can really access anything from the cloud. There's so much power you can do with this. Texas Instruments, what we make is the integrated circuits, the chips that go into these Bluetooth smart devices or these Bluetooth Low Energy devices. Everything from these proximity tags. Zom and Schneider is putting a proximity tag in a pen. Bicycle sensors, like the Sound of Motion bicycle sensor. Blast Motion on the bottom left. This is a pretty cool product. These guys actually integrated a Bluetooth Low Energy radio into the head of a golf club. And what they do is they have technology using some accelerometers in the golf club to do swing analysis. So every time you hit the ball, it will do some analysis, tell you how far you hit it, tell you your swing speed, send that data to your phone. Your phone sends it to the cloud, and this ties into a whole service they have. You're tracking how much better you're getting, or if it was me, how much worse you're getting over time at golf. Connected watches, IDT, Citizen, MonBaby. This is a kind of cool product. It's a baby monitor. It monitors your baby's temperature and makes sure the baby's moving for, make sure your baby's active and keeps track of it on your phone. I think we've gone through these. I'm going to skip ahead. So one of the keys that I think Bob mentioned here is one of the benefits is it's easy to connect. One of the difficulties with classic Bluetooth was this need for MFI authentication, and Apple's really done a great job with core Bluetooth of really enabling Bluetooth Low Energy in a much friendlier way than before. No one needs to join the MFI program. Anyone can make a device like this. They don't need to put an extra authentication chip. Anyone can write an app. It's just like submitting any other app to the App Store. And with core Bluetooth, they've given access that goes beyond just standard profiles. You literally can make any type of device as long as you follow the Bluetooth core specification and really be creative with what you do. The solution cost is fairly low. In addition, if you don't have hardware experience, there's devices like this, like the sensor tag, which I'll be showing a demo of this in the lab next door. Feel free to come by and I can show you what you can do with this. But then there's also hardware partners we work with, like Blue Giga, who's going to speak later, who can make different hardware solutions for you, and then you can write the app and focus on what you know best and really enable different types of applications. Some of the other products, like the connected watches, these companies are actually releasing SDKs to enable app developers to take their hardware and add more functionality to it. So it could be something like devices where it's monitoring a Twitter feed and sending the data to your watch, so someone can actually read tweets from their watch or read their Facebook posts. There's a lot of different things, and it's really open for you to come up with great ideas here. What Texas Instruments offer is the CC2540 and 41. These are our chips for Bluetooth Low Energy. Our stack is provided royalty-free. We provide sample applications. We provide a lot of different profiles that are certified, and even some custom profiles to really kind of enable you to take it to your, come up with your own ideas for how to use this. Our product is very mature. It's been on the market for about 2.5 years. It was the first single-mode Bluetooth Low Energy chip that was on the market and first stack that was certified. We have kits such as the sensor kit. Again, I'll show some demos next door. The CC2540 Mini DK, this comes with a device, we call it the key fob. It has a couple of buttons, a buzzer on it, an accelerometer, and an LED. USB dongles, PC tools, things to get you going. We also have a remote control reference design. This is a motion remote control, so it can be used as a mouse, but it can also be used to control games and those types of applications. And the sensor tag here, this is an app that we have on the App Store. This sensor tag right here, it has temperature, humidity, and pressure sensors, an accelerometer, and a gyroscope, and a magnetometer, some buttons. One of our hardware teams actually made a demo app where what they did was they bought some of the stuffed Angry Birds toys. They stuffed one of these inside of the bird, got the green pigs, made a slingshot, and actually made a real Angry Birds game where they'd shoot the birds, and then the accelerometer data on here would send the signal to a PC and actually control the Angry Birds game. So some fun stuff. I think we're going to post a YouTube video of that soon. So pretty cool. But with all these sensors here, we're really looking to see creative ideas from you guys, from app developers. And for something like this, we provide all the software on the tag. So if you don't want to touch the embedded code, you don't have to. We have our iOS sensor tag app, which will give you access to all of the sensor data. And in addition, we can give the code for this app as well, so you can kind of understand how core Bluetooth works, how we read this sensor data, and be creative, see what you can do. This is just a picture of the hardware to show you what you're dealing with here. This runs on a coin cell battery, so depending on how much you're using it and how often you're connecting to the phone, in most cases, you should be able to get years of battery life with this thing, probably for the life of the product, never have to change the battery. Our kits also, these are all FCC, ETSI certified, so you don't need to worry about any of the hardware stuff. It's really pretty much ready to go. In addition, if you're interested in developing your own hardware, we do have all of the CAD files and things for this as well as other designs, so you can copy our reference designs and make your own hardware systems for it. So that's all I have, and I'm not sure who's next. I think from Blue Giga is next. So thank you very much.
Hello, my name is Jeff Roberg. I am the Senior Field Application Engineer for Blue Giga Technologies here in the Americas region. And I will be discussing how to create a project with the Blue Giga BLE112 module, which is a single mode device that incorporates the CC2540 processor from Texas Instruments. So this is fairly technical, and I may have to rush through a couple of the slides because there's a lot of information there, but I'll have some demos again in the lab afterwards, and all of this presentation and the source code is available on the GitHub repository. So the project that ends up on our BLE112 module is primarily defined with XML. It involves a GATT database definition, which is what establishes the profile, or whether it's an official adopted profile like a heart rate sensor or a custom profile that you might want for your own kind of application. Then there's a hardware definition which tells the module how to function, whether you want to use external interfaces like UART or USB or I2C, a few different options there. If you want to do particular low power sleep modes for extended battery life, that sort of thing, then a USB control file. If you want to use USB, you can do that with that particular module. And the output file for the firmware image that will be created. And then specifically for this demo, and one of the most convenient selling points for this module is the on-chip application that you can actually do with our own BlueGiga BG script language, which is a very, very simple language that makes it easy to create a whole application and run right on the module with no external hardware. So something like what he showed you before, this simple temperature sensor, doesn't require any external components or a microcontroller because it gets to use that CC2540 right on the chip. The gat.xml file contains the definition of profiles which are made up of services and characteristics. Each service has at least one characteristic in it. Each profile is made up of services, so it's kind of a three-tiered system that involves those different types of data. And you can go to the Bluetooth SIG website to see how their official adopted ones are formed and create them very easily with our XML structure. I'll have some examples on a later slide. But you also have the ability to create your own GAT structures very, very simply with this file. We have some documentation that describes how to do that in pretty great detail on our support website. The different parameters that you can set, there's kind of a lot of data here. You can read and write from, say, your iPhone to the module. You can subscribe to what are called notifications or indications, which is how the module can just actively push data to you without asking for it. You can require authentication, so a connection has to be encrypted before an iPhone can access certain kinds of data or all of the data, depending on how your application needs to function. So you have a lot of flexibility with very, very simple parameters that you just specify inside that GAT XML file. Here's a quick example. It's probably kind of hard to read all that, but it abstracts some of the finer, lower-level details of how GAT databases need to be defined into something that's pretty self-explanatory. You establish a service, give it a UUID tag, tell it whether or not you want to advertise, and that's something that is particularly relevant for iOS development because most of the time, an iOS app is going to scan for devices that it can connect to based on a particular service that has to be advertised in order to show up in the scan. And if that service is UUID, like the heart rate sensor, for example, with the 2A37 you can see up there, if that UUID is not in the advertisement packet, then it just won't show up in your device, in your iOS app. So that's something that gets some people when they first start. They're like, I can't see the device. I know it's advertising. Well, it doesn't have the UUID in there. So rather than being complicated, all you have to do with our profile development toolkit here is put advertise equals true. It's a very simple parameter to that tag, and then it'll be included in the advertisement packet automatically for you. The project structure for an example BG script project, it's going to involve a project.xml file, which includes just the list of a couple of the subcomponents, the GAT structure, the hardware structure, the application configuration, and the BG script source code, if you're using BG script for a sort of on-module application. And the breakdown is fairly simple. None of these files are particularly complicated, with the possible exception of the BG script application, and that'll depend on what your module needs to do. So that can be as simple as just turning on advertising and reporting, for example, the ambient temperature, or it can be something that's far more involved, like a full-featured glucose sensor, which is something that I have a demo of I'll have in the lab later. And actually, the CC2540 chip that's powering our module has a powerful enough microcontroller in it that you can really run a whole glucose sensor right on the chip itself. It's got non-volatile flash memory storage for storing records. It's got some digital interfaces like I2C or SPI that you might interface with an actual glucose sensor. It's got an ADC for reading analog values and converting them to digital so you can report it to your iOS app. It's very, very full-featured, which lowers the cost for if you're developing a hardware solution. You don't need a lot of external components. So BGScript is an event-driven language. It uses underneath the BG API language and abstracts that into a basic-like syntax. We don't have a development environment for it yet, like a full-featured specific IDE, but it's very easy to use just a regular text editor or a programmer's code editor, that kind of thing for it. The flow of the program is easy to follow. It goes from top to bottom inside each event handler. It's typical for what you might see in a scripting language like that. And basically, you just define an event handler, like you see there, event hardware IO port status. That's used for detecting like a button press, say an external interrupt if you need to trigger a glucose reading or send new data, something like that. And inside each event handler, you just write simple commands that tell the module to do certain things, do basic operations in the script itself, and then you have the end of the event handler there. And it's entirely event-based. You have a system boot event, which gives you kind of an entry point, and then a large variety of other functionality that you can get with many other events. And those are all documented in our API reference guide. Visually, the structure of a BGScript application looks like this. This is all self-contained on the module. It's a full stack device, so you don't need any external Bluetooth stack on your hardware. It runs everything right on the chip because, again, of the CC2540, it has the ability to do all of this. And you have the smart RF stack, the API protocol, which is abstracted into simple BGScript language there. An example hardware setup. I'll just go through this really briefly. Actually, I'll probably skip over some of that. It'll be more easily explained in a demo. But this just configures it to use BGScript, transmit at full power, enable sleep modes, don't use the USB port, which saves a lot of power. USB eats power on the scale of Bluetooth smart devices anyway. It has a UART interface that's used for debug data output. BG API is, I'll probably gloss over this here, this allows you to use our module from an external host like a microcontroller. And it gives you the exact same feature set. It gives you a little more flexibility because using a microcontroller tends to be faster than using the interpreted BGScript application language on the module just because there's less overhead. Requires a little more hardware, but gives you more flexibility. And that's something that you would control over UART or USB. We have a USB module that incorporates the same hardware, same internal CPU, uses the same language, and a lot of times that's a very easy way to get started on a PC end of things. So you can use this BG API control to use Bluetooth Low Energy on a host device that might not have it built in. We provide a reference implementation of what we call BGLib, which is just a set of C functions that allow you to easily use those API commands from different hosts. A lot of people have ported those to different platforms like Arduino, AVR, MSP430, a lot of different options. And there are some PC-based libraries as well for like .NET. I believe Tim Burks has actually worked on one for Mac OS X. So this is the architecture for BG API application. It's kind of the same, but instead of having that on-module BG script application, instead you talk directly via API commands from an external microcontroller. The hardware setup is very, very similar. There's just a small difference in where you're telling the UART to point to, where to listen for commands from, and we've disabled scripting. I'm going to breeze through this because I have a minute and a half. The glucose demo that I have, I don't have a good way to show easily in action, but I can show you in the lab. It runs on our development kit board, which has a connected LCD on board. It's got a potentiometer, which we use to emulate a glucose concentration reading. And other than that, everything runs right on the module itself. So it's a very simple project definition file. This is the contents of project.xml. We've got a GATT database, a simple hardware file, a glucose script, and the firmware image. I will not detail this. For the glucose profile, this is something that's defined by the Bluetooth SIG. This is an officially adopted profile. It requires the generic access service. That actually is a service that every Bluetooth low energy device must have. It includes things like the device name, what kind of a device it is, sort of like the class of device in classic Bluetooth, whether it's a heart rate sensor or just various different kinds of things. Then the glucose service itself has a measurement context, which is basically just extra information if it's available. Feature set of the hardware sensor itself, and then what's called a record access control point. The first three services you can access without authentication. You don't have to pair with the device. You can just connect and read. The third one allows for access of stored records, and in order to do that, because it's a medical device, you have to encrypt the link first. And then there's the device information service, which just has a little info on the manufacturer, say the model number, system ID. That's specified as a requirement in the official glucose profile. Here's a quick visual representation of what that looks like. Profile is made up of 3 services. Glucose service has 4 characteristics in it, and I didn't detail the characteristics in the other services, but those are spelled out on the SIG website. There are 6 events that this demo uses. System boot, connection status, which is it happens when you connect to it from an iOS device. Attribute write, which is what happens if the iPhone sends a command to the module, such as send me back all available records. Hardware I/O status, which on the dev kit there are 4 buttons which are used for triggering a new reading or resetting the connections, things like that. Hardware timer, which is just a single 1-second tick value that's used for simple animation actually on the little LCD on board. And ADC result, which is what uses what reads the value from the potentiometer on board to emulate a glucose concentration. The tools we provide for building these projects are very simple. GUI. Once you create the project files, all you need to do is feed it the main project.xml definition file. Click update. It'll automatically compile it and flash it onto the board for you. If you have a CC debugger, which comes with the development kit we provide, and it's made actually by Texas Instruments. It's a very, very simple process, and that's essentially what the demo board looks like with the code that I've got running on it. It communicates, because it's an officially adopted app, it's a standard, or not app, profile, it's standardized. So this is an app by Nordic Semiconductor, actually, which you can use to test the glucose profile. And it works perfectly, despite the fact we didn't write it. So it involves a encrypted connection, so you actually get to pair with it, so you can use that record access control point. They call that bonding in Bluetooth Low Energy terminology. It's basically the same thing as pairing in classical Bluetooth. And you can trigger new reads. It automatically pushes the data out to the iOS app, which you can then read or access through the access control point with those first, last, and all buttons. Again, as I mentioned briefly earlier, you can store, because of the flash on the module, you can store up to 127 records right on the chip itself, no external hardware necessary. And you can retrieve them all at will. And that's all I have for now. And I have a demo of this and another simple application that I'll have in the lab. So thank you for your attention.
Morning. My name is Ilya. I'm the co-founder and CTO of Revolve Robotics. We're a San Francisco robotics startup based out of the hardware incubator Lemnos Labs. And before I jump into and talk about our specific project, I wanted to just real quick tell you that robotics is really, really hard. Especially consumer robotics is really, really hard. The hardware is usually pretty scary for real developers. I mean, yeah, there's a lot of mechatronics and kind of hybrid people out there, but the people who write really cool code typically don't want to deal with the hardware. And the software is even scarier for us hardware guys. And electrical, which is a kind of a big part of it, is just black magic to both of those people. And it's kind of an important part of it. And all of these people have fundamentally different ways of thinking, different schools of thought, different ways of approaching problems. And there's really has not been a good unified system, no ecosystem, nothing like the App Store, nothing like Android Play for the robotics world. There's a couple of people trying it, but all the other pieces are missing, I feel like. But now with the mobile revolution, there's definitely a new hope, and that's what Revolve Robotics is focusing on. It's mobile computer-based robotics. Now, all of you in your pockets right now have really, really powerful computers that are amazingly cheap for what they can do, especially when it comes to robotics. All of these devices have had billions of dollars of research already spent on making them a really streamlined, fully integrated user experience. All the pieces already talk to each other. And for software developers, it's very easy to abstract out the hardware. There's an established ecosystem, like I said. There's a distribution network called the App Store that has millions and millions of users. And because of that, there's a massive talent pool of developers, such as yourselves. So we spent a lot of money on our video to describe our product, so I'll just play that now, because I have to. It'll be way more efficient at describing it than I can be. So if we can get sound and dim the lights.
Face to face with others, be anywhere in the world, from conference.
But until now, video calling on tablets leaves a lot to be desired.
We don't feel that that tablet experience is really what people are looking for, that they don't have the control that they need to really interact in remote environments. So imagine if you could actually look around somewhere else in the world and you control where you look, who you're talking to, and how you interact.
It takes the burden off the people on the other side, and it lets you focus on the connection. It lets you be back in touch with the people you're trying to communicate with.
So Kubi means neck in Japanese, and it's a robotics stand for tablets that lets you remotely control where you look over the web.
The Kubi gives you control of 300 degrees of pan and 90 degrees of tilt, so you're actually in control of the camera and the video feed at the same time.
So you can see them, they can see you, anywhere in the room. You can follow the action.
It's a really natural experience that actually gets the Kubi out of the way and lets your loved ones enjoy the experience without even knowing it's there.
So Ilya and I worked together for 7 years at our last startup, successfully bringing consumer products to market.
After that company was acquired, we decided to go off on our own and really get into robotics.
Like most great innovations, Kubi was born out of passion.
I've been into robots for a really long time. I started out fighting robots on Comedy Central and BattleBots, and been into just about every kind of robotics since then. And I really believe this product is a way to get robotics into the mainstream. We really want to bring telepresence to everybody. This is not something that just a huge corporation should be able to afford with these expensive roaming robots. No, I want my mother to have one, I want my grandmother to have one, I want my wife to have one. Everybody needs to have telepresence. It's awesome. We really designed the Kubi to be compatible with just about any tablet on the market equipped with Bluetooth 4.0. It's not connector specific, it's not form factor specific, it just works with any Bluetooth 4.0 enabled device. We're opening up to all developers on any operating system so they could really go crazy with it. We want people to come up with really wild applications for this thing beyond telepresence. And that's the point of using tablets for robotics, is it's fully upgradable through software.
We're looking for support to bring this to full production and complete a user-friendly app.
And as soon as we explain to somebody what the Kubi does, they get it. Everybody's been through the problems we're trying to solve.
We'd love to make this happen, and with the support of this campaign, we can make Kubi a reality.
This has really been a labor of love, and it's a labor of love because it's a product that I believe in, that I've actually used with my family.
And that's why we created Kubi.
So we had a pretty successful, fairly successful Indiegogo campaign wrap up last week, and we're going to be going ahead with producing this product. And really, the cornerstone of this whole hardware platform is the BlueGiga BLE 112 module. And what we did was we took the module, we took an off-the-shelf servo system. These are little motors that run on a serial bus, and if you went to CS this year, you probably saw these little humanoid robots doing Gangnam Style everywhere. That's what the system is based on, and because there's no MFI, there's everything is essentially these blocks that we're able to piece together. We did this in 2 months, and by prototype, I don't mean just the piece of hardware. I mean an actual iOS app that talks to our hardware and makes it move, which is really cool. And we didn't have to deal with Apple. We just made this work. The way the system works is there's 2 ways to control the Kubi. There's a fully integrated app that you use on-screen controls laid over the video to control this thing over the web. And then there's what I'll talk about a little bit more. That's the web interface, where you can use the web interface in parallel with any video chat client. And the way that one works is on the remote side or on the web side, there's the Ajax user interface, so basically a web page that's served by our AWS server. The server talks to Apple's push notification service. So when a user submits a command on the web page, it gets pushed to the Kubi app that's running on the iOS tablet. That series of commands gets written to a BlueGiga or a core Bluetooth characteristic that then gets beamed over to the BLE module that then gets broadcast out to the servo bus. And we're using absolute position, so instead of go left, go right, we're saying go to position X, position Y, so it goes to an absolute position. And that's essentially 2 bytes for each position, perfect for Bluetooth, Bluetooth low energy. We write to a BLE characteristic. It gets beamed over magically to the BLE module. There's a BG script, quick little thing that converts just the formatting of the serial string. We step up the serial output of the BlueGiga module and broadcast it out to the servo bus. Now, our robot right now just has pan and tilt servos. That's 2 channels, but you can add actually up to 254 more servos. So our dev kit is expandable. We want to add Nerf guns to it or lasers or whatever. And there's essentially no hardware change, and you just write to that new servo through that serial bus. It's super convenient. There's really nothing for a developer to wire up. And the command is very simple. It's send to servo number whatever. a command. There's a number of commands like go to position, go to a position at a certain speed, just servo motion parameters, and then there's 2 bytes for a high byte and a low byte for the actual instruction value. And this 4-byte variable, it's perfect for BLE. We're sending it relatively slow. Most robot control loops are like 100 milliseconds, which is fine for this sort of infrastructure. And this architecture has huge advantages for robotics. Once again, there's no MFI from Apple. For a startup, that's huge. They wanted to do a credit check on us before we like had a credit history because we're a startup. So how do you deal with that? It's essentially platform agnostic now. We're focusing on iOS, but there's at least hardware in for Windows, Microsoft Surface, and there's definitely hardware in Android devices. We're still trying to work through what kind of support there is from the software and driver side on those 2 last ones. But it's essentially this kind of open thing that different devices can use to talk to robots. And for robotics, this is huge. The system is upgradable through the tablet. So when the iPad 4 came out, we swapped out the tablet and put in the iPad 4, and our whole ecosystem, our entire robot now had HD video for video conferencing, like instantly. We didn't have to change our app. We didn't have to change our hardware. We just dropped this thing in and it worked. It's great, and that's going to obviously happen in the future. And also, there was the switch from 30-pin to 15-pin connector on the iPad. We didn't have to deal with that because we have no hardwire connection between our robot and our tablet. So we just paired the Bluetooth 4.0 connection, just like we did before, and it just worked. That's crazy. And that makes it hopefully future-proof. I mean, I'm sure Bluetooth 4.0 will stick around for a while, longer than any proprietary connector. And another big thing about it is all of you. So you're the developer community. You could code for our platform. You could code for this ecosystem without having to worry about hardware. And that's it. Thank you. And we're doing demos in the lab right after this.